Okay, welcome to Database Management System, CIS 420 class. In this lectures, we're going to cover chapter 1 of the course textbook, which is Introduction to Relational Databases. So our main objective is to understand the terminologies in database management system, such as tables, columns, rows, cells, primary keys, unique keys, and foreign keys. We're also going to identify the 3 types of relationships that can exist between 2 tables in database relational system. Also, we're going to describe the way columns in a table are defined using the data types, null value, and default values. Also, we're going to describe how an entity relationship diagram can show how tables in a database are defined and related. And also, we're going to describe the difference between DML and DDL. Again, the SQL consists of 2 major parts, which is the DML. DML is where we write mostly the queries, select statements. And DML stands for data manipulation language. DDL statements, normally we use it to create our database and also database objects, such as table, views, etc. And DDL stands for data definition language. So first we start with the SQL interface, and we say the application software communicates with the database management system by sending the SQL queries through the data access API. API stands for the application program interface. So when the database management system receives a query, it provides a service like returning the requested data, that's the query result, to the client. So SQL stands for Structured Query Language. And that's the language we are going to focus in this course. So this is what we're trying to explain. So we can see here we have again a network system with application server. The client server is where the user normally interface with the system. If we have a network system, then we may have a database server. The database server is where the database management system application is installed, and also the data informations of the organization is also installed. Then we may have the application server, which will interact with the database server. So when the user requests a service, it goes to the application server. Then the application server gives the SQL queries to the database server, and database server will give us a result. The result will go through the client user interface. So we have user request, the direction of the arrow going to the application server. Then from there, we have SQL queries to the database server. Database server gives us the result. The result will go through the application server, then through the client's computer. So here in this course, we are going to create a database named AP and 4 tables. So example given here, we have a vendors table in an account payable database. Again, the database name will be AP, which stands for account payable database. So in this relational databases, as we said, consists of tables. And we may have more than 1 table, and there will be a relationship between the tables. So here we have a table named vendors, and table normally consists of columns or the field names. The rows will be the records. So in this case, we have 12 records showing on our screen from 1 to 12. The column name, we have the vendor ID, we have the vendor name, vendor address 1, vendor address 2, and the vendor city. We may have more fields, but again, this is what we are seeing right now. Now, the primary key field will be the field that uniquely identifies each record. We don't want to have a duplicate of the records in the table. This means we are going to use more resources and also time consuming. So for example, we know Amazon have millions of customers around the world, even employees too, hundreds or even thousands of employees. Now, we don't want to enter the same customer more than once or the same employee more than once, which means we are going to waste time to enter and also the computer memory, the resources. So in a database system, always our table may have a special field called the primary key field that will uniquely identify each record. So for example, if we have employee table, most likely we can use employee ID as the primary key field because two employees cannot have the same ID number. It's like a social security number. So in this vendors table, we have vendor ID will be our primary key field. And if we look at the records, we can see that the numbers are generated from 1 up to 12. They are all unique. We can't repeat the same number twice. We may discuss about primary key, foreign key again in our future lectures. So the terms we have to know in Unit 1 or Chapter 1 of our course is what is a relational database. So a relational database, again, is a database that normally consists of tables. A table can be called a relation. And these tables have a relationship. And let's say we have 2 or more tables and there'll be a relationship between the tables. A table normally consists of rows and columns. This is the backbone of the database where all our information will be stored. Then a database with a table may have a column. So a column will be only one field name of the, this can be a table or the entity. So for example, if we have a student table, one column name can be student name or student last name. A row will be one record. So one student, we have his last name, first name, address, grade, and all this information is one row. It's called a record. A cell will be the intersection of the row and column. So we'll go back to our previous example. So here we can say we have a cell then where we have intersection of the first row and the second column is a cell, which is the name is US Postal Service. Again, the column name, also we use the term, the field name is US Postal Service. The vendor ID is 1. So all the information in the first row is called a record or a row, which will represent one entity, for example, one student or one inventory product, etc. A primary key will be, as we said, a column that uniquely identifies each record. A composite primary key, sometimes we may have a table whereby we need at least a minimum of 2 or more fields in order to uniquely identify each record. So a primary key normally is one field that uniquely identifies each record. When we say a composite primary key, it means we have more than one field that uniquely identify each record. Then we may have the non-primary key, for example, last name, first name. 2 students may have the same last name, 2 students may have the same first name. So we may have non-primary key, which is a unique key. Then also index. Index allows us to access our data very quickly, efficiently. We may discuss about that also in the future lectures. So this is a relationship between 2 tables. You can see we have a table here. We will call this table a vendor table because we can see the vendor ID, vendor name, vendor address, and vendor city. Then the second table, we have the column invoice ID, vendor ID, invoice number, invoice and date. So we may call the second table as invoice table, the first table as vendor table. Now here we can see there's a relationship between the 2 tables. The vendor ID is a primary key field. Now when you are creating a relationship between two tables, we always use the primary key field. So secondly, we also have a vendor ID in the second table, which is the invoice table, but we will call it the foreign key. So this tells us that we have one-to-many relationship. We can see that we have a vendor ID 123 information, but 123 vendor ID have 5 invoices, 5 different invoices. So we can see that the vendor ID appear 5 times, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this will tell us that we have one-to-many relationship between vendor table, again, the top table, and the invoice table, the down table. So always when we are creating a relationship between 2 fields, we always use the primary key field. So vendor ID is a primary key field in vendor's table. So it appears only once. But vendor ID field is a foreign key or secondary key. Sometimes we use the term secondary key or foreign key in invoice table. And we may discuss this more detail, and we may write a SQL command that make it possible also. So the terms we should know about table relationship will be the foreign key. As we said, the foreign key allows us to create a relationship between 2 tables, and the foreign key is a primary key in another table. Now, when we are creating a relationship between 2 tables, we want to make sure there's no any errors data in terms of if I updated or delete or enter new information in the first table, it should be updated in the second table, the table that you have a relationship with. So here we have to enforce what we call the referential integrity to make sure, again, data will be consistent and no error. We also have one-to-many relationship means, as we said earlier, one table may have only unique field. Then the second table that you have a relationship can have many fields. So one-to-many means, again, we have a vendor ID can be entered only once in the vendor table, but it can enter as many as we want in the invoice table. So we have one-to-many relationship. Sometimes also we have one-to-one relationship, which means both relationship that field should be unique. And we may have many-to-many relationship also. So these are the 3 major relationships among tables in a database system: one-to-many, one-to-one, many-to-many. We may discuss this more detail later on. So in this course, we are going to use MySQL. And in this screen we are seeing here, this is the screenshot of the workbench. So here we create a columns of the invoice table. So first column name is invoice ID. We have vendor ID. Vendor ID will be the foreign key because it's a primary key in vendor table. So anytime we create a field, we may have the field name or the column name. Then also we have to add the data type. The data type will tell us what type of data we can store in that column name or in that field. So for example, in invoice ID, the data type is int, which means we can put digits. And they have 11 here, which means we can go up to 11 digits. Then we have PK stand for primary key. So the invoice ID, we are going to identify it as a primary key field. And again, we may discuss this in the future lab work. Also, when we have a field, as we said, there's a data type. We are using MySQL in this course. So MySQL data types can be char, which is character, or varchar, many characters. We can have int means a whole number. Decimal means a decimal number. Same thing applies to float, also means a decimal number. Now, the difference between decimal and float is the number of decimal places, which we call the precisions. It depends. And also we have a data type for date, if we are storing date in a specific column. Now, in terms to know about columns, we should know the data type. Again, data type represents the type of data we can store in that column. And we saw example, a character or a text or a whole number, which is int, or a decimal number or a date. A no value means in that very column, we can leave it empty. And no value means there's nothing, even if we have a, let's say, a column name balance account, and we put 0. 0 is a value. But a null value means we don't put nothing, it's empty. So normally when we have a unique field like a primary key field, we always specify that not null is not allowed. Null is not allowed. So always we say not null. We will select not null, so that because that is a primary key field, is a field that uniquely will identify each record. So if we left it with nothing, then it cannot do its work. So primary key field always will be not null. Default value means anytime we enter a record, a special default value will appear. For example, I know all my customers are from New York. New York State is NY, abbreviation of NY. So in the state field, instead of always typing NY, I can have a default value for state field as NY. So when I start to enter a record, the NY will come by itself. I don't need to type it. Also, when we have a primary key field, if we don't want to generate the numbers, we can use what we call the auto or automatic increment column, which means when I enter the first value or the first record, the number will be 1, start from 1. Second will be 2, 3, 4 going. So auto increment. Now, when you select a data type as an auto increment, you can specify, you don't have to start from 0 or 1. By default, start from 1. You can specify that, okay, I want to start from 10,000 or I want to start from 500. And also you can specify that you want increment of 5 instead of from 1,000 to 1,001, I want from 1,000 to 1,005, etc. So auto increment column again is a data type. Normally it's a whole number increment by how you specify. By default, it will start from 1, 2, 3, increment by 1. But you can start from any number and you can increment by any number. So this is what we're going to do in the lab work. This is again chapter 1 of the course textbook. So the first thing we're going to do, we are going to create our account payable database. When we create our account payable database, we are going to use it throughout the course. We're going to write a lot of select statements, indices, we're going to create views, queries, everything. So this is how the database will look like. It will have 5 tables. The first table is vendors. You can see vendors have a relationship with a second table named terms. Terms also have a relationship with another table named invoices. Invoices have a relationship with the terms table, which is one-to-many, and also invoice have a relationship with vendors, which is also one-to-many relationship. Then we also have invoice line items, which have a relationship with invoice table also. So again, we will go through in chapter 2, we will go through all the scripts, the command, the SQL command to create all these tables in the database also. So knowing how a standard SQL can help us, say how knowing standard SQL helps you. We say basic SQL statements are the same for all dialects. And what we mean by all dialects is that in database system, we have different vendors. For example, Sybase, Microsoft Access, Oracle, etc., or MySQL, which is the one we are using for this course. And the standard SQL script, we can use it for most every different types of database vendors name. So once you know one, for example, once you know how to write SQL for my SQL database or for Access or Oracle, it's easy to learn the rest because, again, SQL is a standard language for database system. Also, how knowing standard SQL does not help you. Here we say most applications require modification when moved to another database. For example, sometimes we have some data types in Oracle, which is not in MySQL. Still, we can say SQL is a standard language, but sometimes we may have a little bit differences, like data types more or less in different vendors. So this is our first database release, was Oracle 1979. And when we say a database, we mean the relational database release. Before 1979, we have files are normally stored like a text file, and not a relational database system, but we still have a storage system, but it's not relational database. The first relational database system, which we call the database management system, was released by Oracle in 1979. Then IBM released DB2, which is database 2 in 1985. Then Microsoft released SQL Server, 1987. Then MySQL again is a free open source database system, was released 2000. Now the primary platforms for Oracle database can be used in Unix operating system or OS 390 ZOS. Also the same to the database tool by IBM can be used in Unix and also OS 390. But SQL Server again from Microsoft Corporation. So it runs on Windows. MySQL is the best. It runs on the three major platforms: Unix, Windows, and also Mac OS. Again, MySQL is a free open source. Oracle belongs to a company, it's not free. DB2 also for IBM company, SQL for Microsoft. But MySQL, again, is an open source and free. Now with the SQL, we have the DML statement, which is the data manipulation language. For example, we will go through how to write the statement for select, insert, update, and delete. Select is for query. I have a database with students, and students have different types of grade from A, B, C, D, and F. I can say, okay, I'm going to write select statement to only see the students that get only A grade or that have only B grade. So I'll use select. Now, if I want to add a new record to my table, I will use the insert command. Now, if I want to change any value of my records, I can use the update. Update normally go with the set command. So then if I want to delete any item, I can use delete. We can see that delete means we are going to delete a record, but not the whole database or the whole table. Now, if I want to delete a database or object, I will use the command drop. Drop normally belongs to data definition language, DDL statements. So with the DDL statement, we can either create the database objects such as table, index, view, etc. And also we can delete it. We can also alter the table. Alter the table example would be, I'm adding a new foreign key, or I'm adding a new primary key, or I'm deleting some record or deleting some columns. So we'll go through some of the few statements here, but in chapter 2, we may go detail. So first we start with a statement that executes, and when this statement executes, we are going to create a new database. So the command to create a new database in SQL is create database. So create database. AP will be the database name. So I will start with the command create database, then the database name. In this case, I'm creating a database name AP. Now, if I have the database and I want to use it, I can either use my mouse to select the database in my workbench on the navigation area, or I can use the command use. So when I type the command use AP and I run it, AP database will be selected or will be ready to be used. So this example to create a new table. So as we said earlier, we are creating a database named AP, then we are going to create around 4 or 5 tables. This is the database we are going to use throughout the course, the lab work. So we have our database, so first thing we did, we create our database named AP. Now, when you create a database, you want to use it because we want to create a table and etc. So we run the command use AP, or you can use your cursor to select the database. Then first we create a table. So creating a table, we use the command create table, then the table name. So in this case, we are creating a table name invoices. So create table invoices. And the table normally consists of columns. So we have the column names, invoice ID, vendor ID, invoice number, invoice date, invoice total, payment total, credit total, terms ID. Now, when we look at the second column, those are the data type for each column name. So for example, I have invoice ID. The data type is int, which means I can put only whole numbers. I can have only whole numbers there. And also invoice ID is a primary key field. So we have primary key. As we said earlier, primary key field is uniquely identify each record. And the primary key field, we make it auto increment. Here you can see that we have only auto increment, which means by default, we are starting from 1. And we're going to increment by only 1. So we start with 1, 2, 3, 4th record, 5th, 5th record, etc. Now I can also create the auto increment field. Then I can specify, okay, I start from 10,000 and I'll increment by 2. So 10,000, 10,002, 10,004, etc. But we need to specify. Here we just said auto increment. So we start from 1, 2, 3, going. Also, we can see the vendor ID is int. We want to make sure that the vendor ID, the user don't leave that field empty. It must enter a field. So we make sure it's not null. Not null means we must have something there. Even if it's 0, write a 0 instead of leaving it with nothing. Primary key automatically also is not null. We always have to have something. So for example, here we have decimal 9 and 2. This means we can enter a decimal value for invoice total. And 9 means we can have up to 9 digits. 2 means we can have only 2 decimal places. So this would be like a dollar, maybe $20.50. Always the cent will be 2 decimal places. So again, those are all the fields. We will go through all these fields. But again, as we said, int is a whole number. Auto increment, the computer will start from, we didn't specify where to start and how to increment. So to start from 1, increment by 1, which means 1, 2, 3, etc. Varchar means we have more than 1 character here. We can have up to 50 characters for the invoice number. Data type date means we can enter only date in that field. Then the last 3 here, we have decimal, which means decimal value with up to 9 digits, and then 2 decimal places. So 9 means the number of digits. The second value 2 means the number of decimal places. And we also have invoice due date. Then here we are creating a foreign key. So we use the command constraint. The foreign key name is called invoices FK vendors. And we have the command foreign key. But the foreign key will take an argument of the name of the field. So here we want to make invoice in the invoice table. We want to have the vendor ID as a foreign key. You can see that we already, in order to say we have the vendor ID as a foreign key, we should have vendor ID already in the column name. So we can see our second column is vendor ID. Because it's going to be a foreign key, that's why we have not known. So again, the command is constraint. Then the name of the foreign key, invoice FK vendors. Again, name can be any name you choose. But we have to use the command constraint and foreign key. After foreign key, the argument will be the field name, the column name, or the field name that you want to make as a foreign key. Here we are making vendor ID. Vendor ID must be already listed here as a field. So our second column name is vendor ID. We are making it as a foreign key. And this will be referenced. So foreign key make us create a relationship between two tables. So we use the command references to the vendors table. And the vendors table, we are using the vendor ID also. So vendor ID is a primary key field in vendors table, and vendor ID is a foreign key in the invoices table. So we are using it to create a relationship now. So here we have a relationship between, again, an invoice table and vendors table using the vendor ID field to create a relationship. Secondly, we have another relationship here. Again, a table can have as many relationships, depends on the design. So let's go back to the database before. So for example, if we look at generated ledger account database, you have two relationships. You have a relationship between invoice line items, and also it has a relationship between vendors. So if I'm writing this, creating this database, I may have to have two foreign keys. And most of all the tables, they have two relationships. So that's why here we have our second relationship. We use the same command constraint, the name of the foreign key. This time we call it invoices FK terms. The names must be unique. We can't have the same name. So this is called invoices FK vendors. Then we have a foreign key command. What field? Terms ID, which means terms ID must be a field in our invoice table. So when we look down, we can see terms ID here. The data type is int, and also it's not null because it's a foreign key. So that will be the conclusion of our first table. We have our table invoices, has a relationship between vendors, and also another relationship with terms data and table. So we have terms table and vendors table who have a relationship with invoices. So here we say a statement that has a new column to a table. So we already create our table. Now we want to add a new column. Maybe we have 4 columns in the table. We want to update the table to add a new column. So we use the command alter table and then the table name. So this means I want to alter my table name invoices, and I'm going to add a new column named balance due. The balance due data type will be decimal with 9 digits and 2 decimal places. So alter table command allows us to add a new column using the hard clause. So we have alter table, the name of the table invoices, then hard command. What I'm going to add, the column name is balance due. The column always have to have its data type is decimal, 9 digits, 2 decimal places. Now, a statement that will delete the new column, I'm still going to use the alter table and the table name, but this time I'm deleting the column. So I use the clause drop column. What column are you dropping? Balance due. So alter table invoices, then drop the column balance due. The first one is to add the column, so add balance due and the data type. A statement that will create an index on the table, we use the command create index, and the index name can be any name. Here we name it invoices vendor ID index. And we are creating this index on invoices table using again the vendor ID. Then a statement that deletes the new index, we use the command drop index and then the index name. So this is an invoices based table. We have some records. And here we want to write a query to select some items from the table. So this is a select statement that retrieves and also sorts the selected columns and rows. The select statement normally is a query. I have 1,000 students in my course. I want to know all the students from New York State or California state. So I have to write a select statement because I don't need all the students. I only need students from a specific state. So for example, here we are dealing with invoices, account payable database system, vendors we supply items to. So what we are doing here is that we're going to select, and always when you start with the select statement, the next will be the column names. If you are going to select all the fields, we use asterisks. That means you are selecting all the fields in the table. But if we want to, let's say we have 5 columns, but this time we want to select only 2, then we have to write the 2 names. But if I want to select all of them, I'll use the asterisks. So here we say select invoice number, invoice date, invoice total, payment total, credit total. So these are all column names. And also we are going to select some item, but we do some arithmetic operation on it. So we want the value, which will be the balance due. Invoice total minus payment total minus credit total. When we do these calculations, the answer we get, we put it in a new column named balance due. So we use the keyword as balance due. So this means I'm selecting a column, invoice number, invoice date, invoice total, payment total, credit total, and also invoice total minus payment total minus credit total. We have all these 3 columns. So we do the arithmetic operation here. The answer we get, we store it in a new column named balance due. So we use as balance due. This information will come from invoices table. So normally select the column name from what table. And also we have where. Where means if there's any condition. Here we have a condition. We want the balance due to be greater than 0, which means the customer owes some money, or in this case, the vendors or creditor, they owe some money. So our condition says where the invoice total minus payment total minus credit total, that's the balance due formula, is greater than 0. Now, when we get the answer, we want to order it by invoice date, which means we are going to put all the items in invoice date. The earliest will come first. So when you look at the result here, you can see that we have 2018 July 10, then 2018 July 18, 2008, 18 year, July 21, 22, etc. Because we are sorting by date. So if we say order by, we didn't specify whether it's ascending or descending. Ascending means from the earliest to low, the lowest to the highest, or in terms of date, the late to the earliest. So we start from 10 to 22. Descending means the latest to long time ago. So we start from July 22, we go down up to July 10. You can see our last field, balance due, they gave us the calculation for each record with a value. The balance due is a formula we use, invoice total minus payment total minus credit total. Then we have the where condition. So we can see that the balance due values should be at least greater than 0. All the values are positive values and not 0, greater than 0. Now, we also can have a select statement that will join data. We may go this detail somewhere around chapter 4. In SQL, we have different types of join. So for example, here we say select vendor name, invoice number, invoice date, and also invoice total from vendors, inner join invoices. We use join when we want to get information from 2 or more tables. Now, if I'm getting information from 1 table, then I don't need to join 2 tables. So here we can see that the vendor name will be in the vendors table. Invoice number most likely will be in the vendors table and invoice because it's a unique field. But invoice date will be in the invoice table. So we have the vendor name in the vendors table, invoice date in the invoice table. So since we are getting information from 2 or more tables, we create a join. Now, the type of join we are going to use depends on the type of data we need, the answer we need. So here we use the inner join invoices. And also when we join, it's the same concept as we mentioned earlier, with the foreign key and the secondary key. So here you can see that we are joining on vendors table with the vendor ID field. Also invoice table with the vendor's ID. So they must be equal. Where here also the invoice total should be greater than or equal to 500. So that's the condition. And we are going to put this in order by vendor name and also invoice total. Here we can see it's descending. DESC stands for descending. So when we go to the invoice total and also the vendor's name, you can see that we are going to have names. For example, if it's names, normally A come before B, but if it's descending, it means B will come before A. So when we look at the here we say order by vendor name, invoice total, so descending. So we look at the invoice total, we can see that we go from the highest to the lowest. Also a statement that will add a row to the invoice table. So we use the insert command. So the command is insert into the table name invoices. Then the fields that you are inserting to. So I'm inserting to vendor ID, invoice number, invoice date, invoice total, terms ID, invoice due date. Now, the way we arrange the columns here should be the same as the values. So again, values is a command. 12 will go to vendor ID. 3289175 will go to the invoice number. Then the date will go to the invoice date. So we have to make sure that the values, they are in order as the column names also. Now here we have a statement that will change the value of a column for one row. So we use the command update to change. And when we say alter, we are changing, for example, the column name, the field. But update means we are changing the record. So here, update invoices, we set the credit total into 35.89. Now, when I'm using alter, either I'm going to add more column names or I'm going to remove a column name, add or drop. But if I want to update a specific value, a record in the table, we use the update command. So you can see we say update. We're going to set the credit total to 35.89 for people or the vendors that their invoice number is 3674447. So if your invoice number is 3674447, your credit total will be $35.89. So here we say update the table name invoices, set credit total equal to 35.89, where the invoice number is this. Another example, a statement that changes the value of a column for multiple rows. So here we are changing the value. Here it's only one row, a row that have invoice number 367447, but here it's multiple row. So we say update invoices, then we are setting the invoice due date, which equal to date had, the invoice due date interval of 30 days, where the terms ID equal to 4. So this statement will change the value of a column for multiple rows because of the condition we have the interval 30 days. A statement that deletes a selected invoice from the invoice table. So if I want to delete an invoice from invoice table, I use the command delete. So delete from invoice, the table, where the invoice number equal to given. So if we see the invoice number 4-342-8069, we are going to delete it, that record. Also a statement that deletes all paid invoices from the invoice table. So we say delete from invoices. Because it's paid, what will happen? The invoice total, which is the bill that we have, the invoice total we have, minus the payment total, what we pay, and also minus if we have any credit before, minus the credit total equal to 0, which means we have paid everything. So we're going to delete. So delete from invoices any record that the balance due is 0. Balance due will be invoice total minus payment total minus credit total. This is another select statement that is difficult to read. Again, as we see earlier, example here, we can write all these statements in one line. But for readability and also to be very clear for us to understand, it's better we use the tab keys or a new line. For example, delete from invoices table, I'll go to the second line where invoice number equal to, instead of writing everything. So this statement is correct. It's the same as the down one, but I would prefer the down one because it's more easy to read. I can see all the columns. Then I can see from, select from, where, order. I know when select come, the rest will be the column names. From, the table name will follow, where there will be a condition that we need. Order by means to sort. But here we write everything and all of them are in lower cases. You can see that here, the second is very good in the sense that more easy to read because the command are uppercase letters and the names, column names, etc. are lowercase. But here everything is lower, which will be difficult to read. So select invoice number, invoice date, invoice total, payment total, credit total, invoice total minus payment total minus credit total as balance due from invoices where, but you can see that everything is in lowercase, but the condition is true. So this is more easy to read, select from, where, order. Now, next also we have a select statement with a block comment. In SQL, same as Java language, we can have a comment in our statements or our file. So for example, here we have a multiple line comment. Actually, this multiple line comment syntax is the same as Java and C++. We start with the / asterisk, then I can write as many lines as we want for comment, then we end it with asterisk and / okay. So here the comment we have is the name of the author, the person who wrote the command or the file, and the date it was written. So when we run this SQL script, the comment area will be ignored by the program. So here we have select invoice number, invoice date, invoice total minus balance total minus credit total as balance due from invoices table. That's it. Also, we may have a select statement with a single line. Normally with single line comment, we use 2 dashes. So this means only one line is the comment. The fourth command calculate the balance due. If we have more than one line, we use the multiple line comment. / asterisk, then we end it with asterisk and /. Here we have only 2 lines, but as we said, the lines can be as many as we want. So coding recommendation, again, we can see the previous, these 2 slides here, we say both are the same. Both, again, scripts are the same. But we can see the second is more easy to read than the first one. We make all the command uppercase and the command start with a new line. I don't want to have 2 commands in one line. So that is the suggestion here. Always we should capitalize the keywords, which will be the commands. Also, always we can use the lowercase for other coding, like the column names, the database name, the conditions, etc. Also, we can use separate the words in names with underscores. So if I have a FK, foreign key, employee ID, I don't want to write with space between, I will use the underscore as the space. So use underscores to separate 2 words. Also, you can start each clause on a new line, and that's very good because as you can see this example, the reading was very good. So each cross starts a new line. We don't want to have two commands in one line, difficult to read. So again, these are just recommendations. The SQL script, we can use lowercase or uppercase for the command. It's up to you. The names, if you like, you can use the underscores. You don't need to. It's up to you. So that will be the conclusion for our first lectures in SQL. Again, this course, we are using my SQL database as our lab. So all the commands we have here will 100% run on my SQL. In our next lectures, we're going to study how, again, to use my workbench and also how to download it. So again, wish everybody the best. Thank you.